What's up, Fortnite gamers? Mr. Top of the right corner of the screen coming at you, and we got another video today, and we're going to be talking about physics. And we kind of just introduced ourselves to this unit in this whole realm of physics, actually. And we're starting out talking about motion and reference frames and relative motion and all these terms that are flying at you, no pun intended. And I know it can get a little confusing, so I wanted to stop, take a moment, post a resource video for you guys in case you were getting a little confused on this whole reference frame kind of relative motion kind of stuff. So let me go and start talking about a reference frame. So a reference frame, all a reference frame is basically the frame of reference. And it's kind of like the scene or whatever you're looking at that you're basing something else's motion off of. For example, if a car you say is going 40 miles per hour, you're saying it's going 40 miles per hour relative to what? Well, we typically use the ground as a reference, or the street or the road or whatever, because we're not saying it's going 40 miles per hour relative to that man jogging over there, or it's not 40 miles per hour relative to the plane up there. We keep the ground as a reference frame for all other types of motion. Typically, as humans, that's what we do. We like to have a concrete reference frame. However, the speed of something is not always going to be the same if you're changing your reference frame. So, for example, if you're on the highway and you're going 60 miles an hour and you look over at a car next to you and they're also going 60 miles an hour, it almost looks like they're not moving at all. Okay, if you were to take out the background, if you weren't able to see that the Earth was moving, they're right next to you and they're not going forward, they're not going backward, they're going the same speed as you. So to you, that car really is going the same speed, or it's essentially not moving at all relative to you. So to the ground, it's going 60 miles per hour, but to you, you guys are kind of just right next to each other, kind of still. So it can get a little confusing a little bit. So I wanted to discuss this. And the homework that I gave you guys was looking at a picture, a scene of a lot of different moving objects or people. And so what we have here is we have a lot of moving objects. We have a battle bus from Fortnite. We have the Goodyear blimp. We have this dude tubing. We got this nice boat. I think that's also from Fortnite. We got the soccer car, and we got a hitchhiker who's just standing there, and we got this skateboarder. All right, and so all of these values that I put here. So like this, the battle bus, it says 20 m/s. That just means meters per second. That's a ratio. That's a speed. So it's basically saying, okay, that bus is going 20 meters per second, kind of like miles per hour, but in science we use meters per second. And so all these have a certain value to them, a certain speed in a way, in a direction. Okay, so the guy down here, it's all in reference to this guy down here with his thumbs up. All right, he's a hitchhiker. So it's all in reference to this guy. He's not moving. He's going 0 meters per second. So he's just standing there. So all of these values, all of these speeds are relative to the hitchhiker down here who is just chilling. Okay. What we want to kind of dive into is, all right, well, what's the speed of things if we were to switch the reference frame? Well, what do I mean by that? Well, like, what's the speed, for example, of this battle bus to the hitchhiker? Well, it's 20 meters per second to the right. But what's the speed of the battle bus to the skateboarder? Well, that's going to be different. If you're talking about what's the speed of the battle bus to the skateboarder here, so this guy's going to have a different view of the speed of this bus than the hitchhiker does, because the skateboarder is moving. All right. Well, the skateboarder is moving 20 meters per second to the right, and the battle bus is also moving 20 meters per second to the right. How fast is the battle bus going relative to the skateboarder? And the answer would be, it's not moving, okay? It's not moving relative. It's not going any speed relative to the skateboarder. Now, I know what you're saying. Well, it is moving. Well, yeah, but you're still stuck in that whole ground mentality. Yeah, it's moving relative to the ground, okay? I get that. But to the skateboarder, okay, from his reference frame, relative to his speed, it's not moving. Okay, they're both going the same speed. So relative to the skateboarder speed, that bus is not moving. And that's kind of what is hard for us to conceptualize, because we're so used to using values from the ground point of view. Okay, so according to this guy who's on a skateboard, if you were to look up at the sky, he's moving alongside the battle bus at the same speed. So they're both technically still. Okay, I know they're not still relative to the ground, but to the skateboarder, they're going the same speed. So there's no motion. Okay. So that's the weird thing about this. All right, well, let's do a different one. Let's say that you're also the skateboarder again, okay? But instead of looking at the battle bus, you're looking at the tuber, okay? You're looking at this guy who's just chilling like that. He's having a good time. Look at him, okay? And he's moving to the right as well, just like the skateboarder is, but he's moving slower, actually a lot slower. He's just kind of drifting. So he's going 2 meters per second to the right, and the skateboarder is going 20 meters per second to the right. So I want you to put yourself on this in the skateboarder's shoes, okay? Imagine you're on the skateboard and you're going 20 meters per second down the road, okay? And you pass this guy right here who's on an inner tube, and he's going a little bit slower. What speed is he going relative to you? Okay, so again, you are the skateboarder. You're this guy right here. That's Joe. And you're looking back at him. What speed is this guy going relative to you? Well, it's not going to be quite 20 meters per second. All right. He's going to be going a little bit slower than 20 meters per second behind you. So how do I know that? Well, imagine this. If he were going, let's say, 20 meters per second to the right, and so is the skateboarder, then they're both going relative to the same speed. You would say, okay, the tuber's not moving relative to you. But he's going 2 meters per second relative to you, okay? So he's actually going to be going 18 meters per second behind you relative to this guy, all right? Because think about it. You're going 20 meters per second. If you're the skateboarder, you're going 20 meters per second to the right. And this guy's also going to the right, but at 2 meters per second. So what you would actually do is if you're this guy who's going 20 meters per second, you're going to take that 20 and subtract that 2, okay? You're going to take that 20 and subtract that 2. If you're going in the same direction, what you do is you subtract the number from the reference frame that you're in to the number of the thing that you're looking at, okay? So 20 minus 2 is going to be 18. So to you, this guy is actually moving at a speed 18 meters per second behind you, okay? It's going to the left. So the way you think about it is, okay, I'm on this guy's skateboard. I'm going to the right. Which direction is this guy moving relative to you? You're like, well, relative to the ground, it's moving to the right. I get it. Relative to the ground, it's moving to the right. But relative to the skateboarder, if you're passing a guy and you're on a skateboard, is that guy going in front of you or behind you? If you're passing him, he's going behind you. So he's actually moving to the left or going behind you in this frame, okay? So I know that's a little weird, but essentially what you do is, okay, you put yourself in the shoes of the object in this picture, okay? And you try to imagine, all right, well, if I'm moving at 20 meters per second, like you are the skateboarder, and you're looking over at that guy who's in the raft, who's moving in the same direction as you relative to the ground, and they're a little bit slower, he's going to be moving behind you. How fast? Well, it's going to be however fast you're moving minus however fast he's moving. Okay, a little confusing. So this guy would be 18 meters per second. All right. Well, let's think about this. Let's keep us the skateboarder. Let's just do everything from the skateboarder. The skateboarder. How fast is the boat moving relative to the skateboarder? Okay. How fast is the boat moving relative to the skateboarder? And, well, let's imagine for a second that the boat's not moving at all, okay? Let's say that it's 0 meters per second. Well, if you're the skateboarding guy, and you're heading towards this boat, how fast is that boat coming towards you? Well, you're like, Cully, it's not moving at all. Again, you're still stuck in that whole ground reference frame. You are the reference frame, all right? So you're saying, how fast is that boat approaching you? If you're on a skateboard, okay, and you're heading towards this boat, how fast is that boat approaching you? And it's going to be, if it's still like it is, it's going to be approaching you at 20 meters per second. Whatever your speed is, it's just coming at you at that speed. Okay, that makes sense. So like if you're in a car going at 40 miles an hour towards a brick wall, which I don't recommend you do, then if you are the reference frame, that brick wall is coming at you at 40 miles per hour. Okay, so it's kind of like if you shift that reference frame, okay, let's say that the car's not moving, that brick wall, in a sense, is coming at you at 40 miles per hour. All right, so the boat would be traveling at you at 20 meters per second if you were, in this case, the skateboarder. But it's not. It says 20 meters per second. So you are on a collision course with this boat. All right, you're going 20 meters per second to the right. This boat is going 20 meters per second to the left. All right, so how fast would that boat be going according to you? Okay, The other way to think about this is if you're on the highway, all right, and you're going 60 miles per hour, and a car coming at you is going 60 miles per hour. Imagine that, okay? Car coming at you is going 60. You're going 60 towards it, which I also don't recommend. How fast is that car going relative to you? Well, to you, it's going to be going 120 miles per hour, because if you're going 60 towards it and it's coming 60 towards you, then you're going to add those speeds together. So you're going to add those speeds together, because technically if you're going toward it at 60, it's coming towards you at 60, then you add those together because you're coming at each other both at 60 miles per hour. So from the skateboarder's reference frame, from the skateboarder here, if the boat's coming at him at 20 and the skateboarder himself is going at 20, really from this guy's point of view, what he's seeing is that that is coming at him at 40 meters per second, okay? So anytime you're going opposite directions, okay, so the skateboarder is going to the right, the boat's going to the left. If they're coming at each other, then you add the values together, all right? So anytime it's the same direction, you subtract. Anytime it is coming at you, then, anytime it's the opposite direction, then you add, all right? So it's a little confusing there. So there's a lot that this kind of, it makes us switch our thinking gears to be in something else's shoes, which is good, but it's just hard to do because we're so used to viewing things in the ground perspective. But when you shift the frame of reference, things get a little bit tricky, and a lot of physics revolves around changing that frame of reference. So this is going to be some of the hardest stuff that we deal with. If you're struggling with this, understand that it's okay. All right, this part's not going to be tested heavily, but I want us to start to think about, okay, how can I think about this world or how things move from a different point of view, okay? So don't freak out. If you're not fully grasping this, that's okay, but I wanted to challenge you to think, okay, how are things moving? Well, again, you and me, we say that if I'm just sitting here, I'm not moving at all. But really, you and I both know that the earth is spinning, okay? So we're actually moving at 700 miles per hour right now relative to the earth spinning. But we're also revolving around the sun at 66,000 miles per hour. Okay, so we are moving. Yeah, but relative to the ground, we're not. So motion is all relative. You and I are moving super fast right now, but that's relative to the sun, or that's relative to a galaxy. You know what I'm saying? So motion is all relative. Speeds are all relative. It's whatever you consider it to be based on the reference frame. And that's what I wanted you to pull from this whole kind of exercise. So again, if you have questions, specific ones, let me know. But I'm not grading for accuracy on this. I just wanted us to challenge to think about, okay, how can I think about myself and things that move from a different point of view?